Hi, this is a Hello World program, your first program using code blocks, using the C++ programming language. First of all, make sure that when you install code blocks, that you install one with the MinGW, because that one contains the C++ compiler. These other ones just have the code blocks IDE without the compiler. Okay. And so now once you launch it, and of course I'm on Windows, once you launch it, I'm going to go to File, New, Empty File. And now the first thing I'm going to do is go ahead and just save it, Save File As. Because you want to let it know that you're saving it with the .cpp extension to let code blocks know that it's a C++ program. So notice by default it wants to save your file name with a .c extension. So that's what we want to change. So I'm going to name it hello, which you can use any file name that you want, but the extension needs to be .cpp. Okay, so now code blocks knows that it's a C++ program. I'm going to zoom in just a little bit. And so now I'm going to type the Hello World program, which is going to start with a #include IOStream. And I will talk about what each one of these lines is after we do it. And then the next line is using namespace std like that. And then int space main, open close parentheses. And then an opening curly brace. Notice that when you do an opening curly brace, it automatically does your closing one and indents you, because all your code in between the braces, which is kind of like a container, should be indented over. Okay, so now the line of code that actually will print Hello World to the screen is cout, console out, and then 2 less than signs, redirect, and then within quotations, you can, whatever you want to print to the screen, for example, hello world. And I'm going to go ahead and do a backslash also. And then this line needs to end with a semicolon, just like that. Okay, now the tools up here, this one is build, which compiles your program, because C++ is a compiled language. You've written your source code, you have to compile it into an executable. And then once you compile it, if it's successful, then the run button will execute the program. And then here's a build and run program tool right here, and that does both of these combined. So I'm going to go ahead and do this, build and run. And so now notice it launched my program. If you'd had an error, it wouldn't have launched it, and I'll demonstrate that in a second. So I went ahead and launched my program, and it printed hello world, which was the output of this cout statement. And by the way, the \n means skip a line. That's why we have this extra blank line right here. Now this other stuff down here, this is not output of your program. This is actually just this is from the code blocks. So you know, it's just telling you how long it took to execute your program. And then it's doing a pause. It's which they press any key to continue, because otherwise this would just this executable would just close out real fast if you don't pause it. So anyway, so now next thing I want to look at is I'm opening up a File Explorer. Okay, so now first of all, in your File Explorer, we're going to look at the files that were created. First of all, make sure that you have your file extensions enabled under the View menu, because by default, they hide the extension that's passed in. If you're working with files, if you're a programmer, you need to have that enabled. Okay, so now, of course, the CPP, hello.cpp, that's our source code file that we created right here. And then when we compiled it, it created an object file, or an intermediate file, where it pulls in the different objects, and this file right here. Of course, you don't need to save that one. And then it actually created our hello.exe. That's our executable program that it created. Okay, so now let's look at what happens if you had an error. Let's say that I left off my semicolon right there. Now when I do my build and run, it's not going to it's not going to launch the program. It didn't create a new executable, but you had an error. Now the output of your compiler is down here in logs, and it will tell you, like right here, here's the line number. And if you have a lot of errors, always fix the first one first, because sometimes the first error will cause other errors to happen. So you always start with the first one. So this tells you what the error is, but it also puts a little red block right here pointing to the line number of where the error is. So I'll put that semicolon back in there. Okay, so now let's talk about what, I'm just going to rebuild it to get rid of my error. And also remember, anytime you make a change to your program, you need to recompile it before you run it. Because if you just run, you'll just run the last one that you had compiled, even though maybe it made changes. So make sure you either do, every time you make a change, do build and run, or just do the combination button right here. Okay, so now let's talk about what each line is. The C++ programming language, along with any programming language, is limited in what they do. So what you do is you pull in libraries of other code that's already been written to do things for you. For example, the square root function is not built into C++, so we have to actually include a math library that contains all the math functions like that. So the top of your C++ program may have one or more pound includes, and those are pulling in libraries of functions that we can use inside of here. And the IOStream library, input output stream, that includes the cout command that allows us to output to the world, output to the screen. Also has the cin statement we use for keyboard input, but I'm not going over that in this video. So that is our IOStream. So if we want to use cout, we need to pound include IOStream. Okay, now this is a little bit more advanced concept, the using namespace standard right there. As a program gets larger and you're using more, you're pulling in more functions, there could be some problems with the variable names, function names, class names colliding. You know, it's kind of like, you know, if you have a class and I'm teaching a class and two people with the exact same name, what do? Well, I go to the ID in that case. What this does is allow you to create separate namespaces if you have multiple functions or classes with the same names. So anyway, the easy way to do it for small programs works great is just to say using namespace standard. So we're basically not having to deal with the namespaces for the system libraries that we include. Okay, so now the next thing is int main. Okay, your C++ code is going to go inside of functions. And so your code may have one or more functions in it. So the function named main is the entry point to your program. So when you compile it, the compiler says, okay, where do we want to begin this, your execution? It looks for a function named main right there. And functions all have an open close parentheses after them. And when you study functions, you'll see how you can declare parameters inside of there. Okay, and functions also return something. Or they could be void where they don't return anything. But the standard way to code C++ is to have your function return an integer. So after this finishes executing, and I actually forgot to put this in there, you should have a return 0. It obviously worked without this in here, but the standard way to code C++ is to have your main function return an integer. And so then the last line of your code would be return 0. And 0 being an integer, that matches this right up here. And basically all that does is when your main returns a 0, what that's doing is that's returning back to the operating system. So, and the 0 means it exited normally. So when your program finishes executing, it tells the operating system 0 that it's finished normally. And so now, so that's the function header for your main right there. And then the opening brace. Functions will always be followed by an opening closing brace. And they are a container that contains all your code. And again, any code inside the closing brace should be indented or tabbed over. And it wants to do that for you. You know, by default, you know, if I do enter, you know, it will leave my indentation right here. Okay. So now the next line of code is cout, and that's actually a function inside of this IOStream library right here, console out. And the way we're using it right here is with the redirect, the two less than signs. So it sends this to that function, the cout function right here. Okay, and so now what we want to output, if we want to output text, it needs to be inside the quotations right here. And so then you can put whatever text you want right there. And the \n means skip to the next line after you finish that. And then code inside of main should end in, the line will end in a semicolon. Just like that one ends in a semicolon also. So that tells you where the line ends. And I'm going to throw one more thing in here, and that is comments. So, you know, when you compile it, the compiler looks at each line of code and converts it into machine language, your executable. But now comments allow you to put code in here, or not put code, to write documentation, to write comments and things that are not compiled, so the compiler will ignore it. And if you start a line with 2 forward slashes, then this is a comment. So I could like put this program was written by me, something like that. Or the comment can go at the end of a line right here, you know, output hello world, something like that. So you can put a comment like that. And that is the C++ style line comment. And there's an older style of comment called a block comment. And a block comment is you start it with a /*, and then you end it with an */. And that will comment out the entire section of code in between that. Where this is just comments out what follows it on the line, this can be used to comment out a block of code. Because when you start working on a larger program, you may have some code that doesn't work yet. You aren't finished with it or something, and so you may just want to comment it out so that the compiler will ignore it, so you can still compile the code that is working. So anyway, so I'm going to take out those comments there, and I think that concludes our Hello World program. Thanks for watching.